Alrighty. Well, welcome everybody to our last Soil CRC Community of Practice meeting for this program. We are negotiating with the Australian Government for a phase 2. So watch this space. We did have a bit of money left over from the project because we didn't travel as much as we had planned to. So we might be able to extend the project. So I'll send you all a survey to complete as a wrapping up of the project. And there's some options there about how you might like to either continue to be involved or stay connected with the community of practice going forward. So keep an eye out for that. And so today I've invited Abby Jenkins from the New South Wales Department of Primary Industry, the Soil Extension Officer, who you all got to meet at our first meeting nearly 2 years ago. So it's fantastic that Abby's been able to come back in, and she's going to take us through some soil pit processes and things that you might want to think about and planning and that sort of thing, and also some supporting characterization data, supporting resources that you can use when you're going through the soil pit from a New South Wales point of view. And I've also invited and have online Andrew Biggs, who's a senior soil scientist from Department of Resources in Queensland and based in Toowoomba. And he is very ably supported by Christy Williams, who's the Land Resource Officer. So between Andrew and Christy, they'll take us through the soil characterisation data that's available for Queensland. So for you Queenslanders, so hopefully that will be helpful. And Andrew's got loads of experience, which is fantastic. And he took us on a tour for the Soil Science Conference up in Cairns through the wet and dry tropics. So that was really fantastic. Kel was on that tour, and James Holding, who's in the Southern group, was on that tour as well. So that's fantastic. So thanks very much, everybody, and welcome, Cole. It's so good to see your face. Last time you were here on the phone, so it's great you've been able to join us. So I guess just a bit of Abby's met you all, so she's aware. But for Andrew and Christy, we've got a mix of project officers from and research officers from northern New South Wales and Queensland, all the way up to sort of the tropics with the sugarcane peeps. So just a bit of a background, and we've been doing some soil capacity building as best we can online. We only got together once, but otherwise we've just been doing these webinars for the last 18 months or so. So I'll kick off and I'll introduce Abby, who will kick off first. And thanks very much, Abby. Poor Abby had some dental work yesterday, so she might not want to show her face, but I'll hand it over to you, Abby. Thanks very much for joining us today.
Thanks, Felicity. Yeah, I don't want to scare everyone. I had one of my front teeth taken out, so I might not use the camera today. So hi, everyone, and good to see you all again. I can't believe it's 2 years. That's amazing. I'll just share my screen. I want that one. And there we go. So hopefully you can see that. Have you got a PowerPoint there, Felicity?
Yes, yeah.
Great.
Perfect.
So as Felicity said, she just asked me to sort of talk to you about some tips and tricks, I guess, about talking to a soil profile. And just before we get into that, I just wanted to sort of preface that by saying I suspect that a lot of you are better at this than you think you are. And sometimes it's just a confidence thing. And so to get over that, I would just say do lots of practice, and even do what I did for this, because I wasn't sure whether I could come today. I actually went out and videoed myself just out on my road because they're doing some road work down there. So that gave me the opportunity to have a look at a soil that had been exposed. And as excruciating as it is, you know, you can watch yourself back and learn from yourself, or even if you're up to it, share with people within this community of practice that you've got going, and learn from one another like that. So let's get on to it. So I guess the most fundamental first question is, why would you want to have a soil pit? And that's really important because that'll determine how many pits you use, where you might site them, what it is that you really want to show. Obviously, I mean, lots of this sounds really sensible, but I think a lot of people go into the digging of the soil pit without actually thinking about that. So, it would, if you wanted to have a comparison, perhaps sometimes you can put those in the 2 pits in different locations, or if you're lucky and you're looking maybe at a cropping situation, you could get something from, like a wheel track across to a bed. Think about those sorts of things. It also determines what kind of demonstration or hands-on activities you might like to focus on. And I would advocate that you try and get people to do all the demonstrations that you do, get them to do it as well, because it just reinforces all their learning about what you're trying to say and what you're trying to focus on. It also obviously determines what kind of expertise you might like to invite to have within the pit with you, because I always find that it's helpful to have more than one person in a pit, because you can kind of bounce off one another. And if you forget something, someone else will probably pick it up. And also who you want to speak to beforehand, to sort of get an idea of the site and what you might see, and that sort of specific expertise. And then obviously what resources you'll need to do all that. So that's the why. The next bit's the digging. And this is just the workplace health and safety slide, really. Oh, we've gone too far. So we want less of this top slide, more of this. And obviously the workplace health and safety stuff's governed by a whole lot of legislation, and each state has their own sort of documents around that, and then safe work methods and all that sort of stuff. So it would be good to look into that, and that governs the things like the depth, width and access of your soil pit. So which is why I put this second picture in, which is a picture of Jason Condon and Helen from New South Wales DPI, and it's a really nice pit, lovely and wide, has a nice sort of batter at either end for people to get in easily. The steep sides are roped off so people can't fall in and break their ankles, should they do that. And then the depth stuff, the thing to remember is that the depth is determined by the profile depth, but as well as the spoil. So if you want to go deeper here, make sure your spoil's as far back as you can, so that's not counted in there. And obviously if you want to go deeper, then I can't remember what the prescribed depth is, it's a metre something, then you're supposed to have shoring and all that sort of stuff. And the other thing to remember, which I haven't written here, is that if you're having someone dig the pit, particularly if they haven't dug a pit before, that they don't drive over the surface of the face that you want to see, so they don't compact that, and so that what you're looking at then is compacted, not what you would normally see in its natural state. So that's something to think of. Obviously there's a whole dial before you dig stuff, which is important to remember, so that you don't get slapped with some kind of fine or have some irate landholder because you've dug through their water pipes or something. And then the thing that I really wanted to impress too is that you don't actually have to use a pit. You can use existing things, and that can be a really good cost-effective way of seeing more, I guess. So you can use road batters, and the video that I made that I'll show a bit later on uses one of those. And then also there's existing excavation sites that you might like to use. The thing about those two is that you'll just need to spend a bit of time cleaning up the face of the soil pit, so you can actually see the true soil and profile, not that bit that's been weathered by that face being open to the elements for ages. Or you can do a thing called a soil peel, which essentially just is spraying a whole lot of latex onto a soil profile and then peeling it off. It's kind of laborious and time consuming, but if you're interested in collecting a soil profile and having it there in the long term, because then you get to keep it, then that might be a good option as well. And if you're interested in that, there's this farm note that Tim Overhue in Western Australia wrote, which sort of outlines that process. So it's a kind of a monolith. And the other thing to use, I guess, is monoliths where they exist. So you might have a soil pit, but then you also might have a couple of monoliths there as a comparison or something, depending on what you want to say. And I know in New South Wales, we've got various collections of those all over the place. So it's just a matter of finding where they are. Like in the North Coast, we've got a bit of a collection that, you know, Kel is aware about. And then I think there's some up in Armidale. I think we have some in Wagga, that sort of thing. So just try and suss those out. So that's the digging bit. Then this is the what do you use bit. And quite like this picture. I think it's from the States, so it doesn't have the tape around the edge like it should, but it just shows you a slightly different way of doing the pit. So it's a walk-in pit, good for smaller groups. And the kit, obviously, a lot of what you will have seen before. Now, although this is not a spade, it's a corer, but you should have a spade, and you could also have a corer as well, and talk about how that's a different way of looking at your soil and the limitations of that compared to other things. There's a tape measure, of course, which is really important to show the depth at which certain things are, and quite like the nifty way that they've used the fluorescent paint here to delineate the different horizons of the soil. So that's a kind of a nifty thing to do as well. Then there's the stuff that you would no doubt be aware of, things like your pH kit, with there's your universal indicator and your white powder, and the water bottle for textures and things like that. Small plastic bowls that are white are really good for doing things like pH, but also things like slaking and dispersion kind of tests. And the white makes it easier for people to see. Then you have something like, I use a screwdriver, other people use a palette knife. These people probably using this GeoPick here to pick back the face. So I said, that's the first thing you have to do to make sure you're seeing the soil as it is in profile, without all the smearing from the excavation machinery that you've used. And you can see they haven't obviously got down to there, because you can still see the teeth marks from the digger. They've also got these really great little things on information cards on spikes, which I think is good. It can help draw people's attention to things that you really want to show and stress. I haven't used the stand bits, that's very fancy. I usually just photocopy something, and then you can laminate it and just put a hole punch in it and then stick it into the face of the soil profile. And it's really good for directing people's attention to things that are smaller that they may not see, like wormholes or different sort of soil features. So that's really good. The other thing that I wanted to point out on this image, which I thought is really cool, is that it looks like they've benched out and taken samples from each of the different horizons here. I don't know if you can see that. So these are larger soil corers, and you could do each of the tests that you do, the texture, your structural stability, your pH, on each of those. So that's kind of a nifty way of presenting that. The other things that you could have in your kit that aren't on the picture are things like a weak acid. So if you think you might have some free lime, you can use that to, it'll fizz, and that's kind of interesting for people to look at. A tarpaulin if you wanted to get samples from elsewhere. And then things like the wire penetrometer and the quadrat, which are homemade bits of equipment that you can find out how to make from the Northern Rivers Soil Health Card. So they're really easy at home things, and can be useful in looking at those things that are a little bit further away from the pit, like the quadrat obviously for your percent ground cover, but you can also throw it around and do organism counts and stuff for your soil biology as well. If people don't want to get their hands dirty with the texture ribboning, you can use the jar test, where you just put a sample in there and shake it up and let it settle. And then obviously there's things like water and all that sort of stuff for washing your hands. So I thought that's a pretty good complete kit. Then, so the basic point of what we're here for is like, what do you look at? And this, this fairly long list, I guess, I've sort of adapted from this book, which is a Western Australian book. And I think if you're unsure or not confident, it's a really good book to work your way through. And you could even do that you have it in the profile or in the pit with you. It takes the perspective of looking at a soil profile for classification purposes, which may not be your purpose, but it goes through each of the sort of things to look at in the tests, and it has how to carry those out. So it's a really good handbook, I think. It's not very big. It's online. So, but the first thing would be, in my opinion, is to talk about where your soil is in the landscape and a little bit about its geological history. And I think it's a really good way of engaging people. They're really interested in, why their soil is the way it is, and and you can relate that to the landscape and what they're seeing. So, generally this relates to this block diagram. The soils and topsoils would be shallower on the tops of hills and closer to the parent material. Gets deeper down as you go down the landscape. Maybe in the valley bottoms you have soils that are not formed on a rock at all, so the parent material might be alluvial, that sort of thing. So that's what you sort of point out. As in the cases here on the North Coast, we have lots of volcanic activities associated with the old Mount Warning caldera and stuff. You could talk about different periods of lava flow and soils that form on them and that sort of thing. So that's all those were. So I've got, I think the next bit's a bit of video. So this is going to be excruciating for me to watch, but I hope you guys get something out of it. So this is the road cutting just up from my road, because they're widening the road, so they've done quite a bit of work. So I thought I'd take the opportunity to look at it. So here we go.
There's no sound, Abby, so you might need to.
Oh, okay. Well, so
okay.
Well, I'll just turn that off then. Basically, I'm just saying they've exposed the face. This is sorry, I'm just listening at the same time. So looking at the soil in the landscape. So we've sort of got hills and so the slope face is roughly westish, which is why you get this nice the sun on the profile, which is also a good thing to think of, because sometimes it's quite hard to see soils in profile and harder to photograph them. So when you're digging your soil pit, perhaps think about that and the time of day that you'll be looking at it and the face that you'll be looking at. And then the other thing is that I have done some pre-work. So I know a little bit about the geological history of this area. So it's a transitional area between the very red ferrosols of the Alstonville Plateau down the rainfall gradient as we come inland. So similar parent material, and I've used this landscape map, which is produced by the New South Wales government, to determine that. And so these soils are similar parent material or same parent material as the ferrosols, but they've been subject to much less weathering. So there's still ferrosols, but they aren't as red as the ones on the Alstonville Plateau. So you could explain that. And then the other thing that we also know about these soils from that soil map is that they can be quite shallow and stony, and we can see that here when the video gets back. And so there's the plateau further to the coast, and down in the valleys we get the alluvial material that forms the cracking vertisols that's used for a lot of the cropping in this area. So I would ask people straight away what they see first to try and get them engaged with the soil profile. So they'll often colour is often the most apparent thing to them. So you can talk to them about what that means in terms of organic matter. You can talk about how the soil is brighter and the colour is different as you go down the profile and as that influence of organic matter is reduced. And then obviously this one you'd also talk about the parent material being really close to the surface, and it's can't quite see in this picture here, but it's all jointed, so it's probably a basalt flow and the soil has formed on top of that. What's kind of missing from there would be really nice to have a tape measure, but it was a bit too high up for me to get to, so I'm just going to go past that one if you can't hear it. So this just sort of recaps on that. So talk about how the soil fits into its position in the landscape and how that might relate to what you're seeing now. Sometimes those soil landscape maps from New South Wales, and I'm not quite sure about other states, have great little what are called topo sequences in them. So you see the landscape and it has all the different sort of soil types that you might see within that landscape. So that's good to show that. Obviously, the total depth of the soil influences how much of that soil a plant can access, and for both nutrients and water. So you could talk about that sort of stuff, what that means in times of water stress if the soil's not that deep. You could look at things about evidence of your plants and animal activity and relate that to depth as well. So the colour is pretty obvious. You could use a Munsell colour chart if you're really into that, but I've not ever used that very much with landholders. I think it's just enough to say that, you know, organic matter will often make it darker. The red often indicates it's highly weathered and there's a lot of iron, those sorts of basic rules of thumb. And then you could talk about, how you might separate that into that profile into horizons, whether it be by colour and or texture and that sort of stuff, and then relate those sorts of things to the different ways those layers behave in terms of water movement, nutrient holding capacity, biological activity, how roots can penetrate, seedlings can emerge, that sort of stuff. And they're the kind of tools you can help use to do that. So I'm going to try and play the next one. I think what I need to do is turn the sound on. So just bear with me and I'll see if I can do that. Sorry, I should have checked this beforehand. That's what I want. Oh, sorry. That's what I want, I think. Let's see how we go. You hearing that?
No.
Oh, bugger.
So I'm not sure if there's something, when I practiced yesterday with a YouTube video, there's something in Zoom. I'm not sure if you've got it, maybe up the top of the screen. Mine says view options, but there might be somewhere where it says turn sound on or share sound.
Audio. Let's just stop that while we're doing that. Sorry, everyone.
Some great facial expressions there. We could just all pretend what you're saying.
It's pretty. Oh dear, it's awful having to watch yourself.
Interpretive dance.
Where I can't get the Zoom to go big now either, so I can't find the sorry, I can't find my Zoom. I'm going to turn this off. My Zoom control panel that you were just talking about, Felicity.
Oh, okay. Yeah, I think, I don't know if it's in the more bit down the bottom or if it was actually somewhere up the top, but I was yeah, practicing with someone because I was using this YouTube video, and there was somewhere I had to go along the top to share the sound. So yeah, you have to
Sorry
that you want to share the sound, and I can't see it at the moment.
Zoom. Oh, look, let's see if I can just talk you through it because I can't seem to find that.
Yeah.
Am I still sharing?
Yes. Yes.
Okay.
Yeah, it's all good.
So I'll just put that. So all I was saying is that I haven't got such a great tape because I had to give all mine away because I don't do this stuff anymore.
You could then also follow that on with a texture, so you could do textures at various levels.
Yes, we can hear it now. That's good.
I won't do that because there's lots of information on the internet about
Sorry,
how
everyone.
to do that. And also you could use the yellow book, so-called, obvious reasons, which has a key in it for determining soil texture and also soil structure. So get a hold of one of those. They're very useful, as well as some other things. And then you could talk about the importance of texture for things like water holding capacity and cation exchange capacity, and then go on to structure and explain the difference between the two. A lot of people, less so now, but used to use those two interchangeably, and obviously they're not the same thing. So the texture is a given. It's a really good thing to encourage people to do and get proficient at, so that they can go and do it on their own properties, won't change, and then they have that sort of baseline soil texture mapping, if you like, for their property, which they can use for management, hopefully. But the structure they can alter, obviously, through their management. So you could talk, again, using the yellow book about structural things like the size and shape of PEDs and how you get large ones and you can break them into smaller bits. So that's your basic PED size is the smallest ones you can break them into. And in the video I've included for you by Ray Wheel, he talks about this. So then, and you could talk about how organic matter plays a role in that structure. So as you can see, hopefully on the video, the top part has better structure or different structure, if you like, from the one below, where there's less the influence of organic matter, more influence from the parent material. And as I said, our parent material here is really close. So the other thing to mention, obviously that's really obvious, hopefully quite obvious when you first open a pit and talk to people and ask them what they see, is the rooting depth. Now, as we said before, this profile is really shallow, so there's some parent material here. And so even though it supports quite large plants like trees, they're obviously dependent on that really top section where all that organic matter is, all that organic life is. There's some ants there I can see, and so you would point that out. And the importance of that is both for the amount of soil that the plants have access to in terms of nutrients, but also water, so particularly in times of water stress. So if you don't have a deep profile, obviously with lots of water holding capacity, then that soil's more prone to drying out and the plants will be at risk of water stress. The other thing to look out here, which I've just noticed, which is great, is that because this is the parent material, and obviously it's weathering rock like this, it's more impervious, so you can sort of see where the water comes down through the profile and hits that and sits and is quite moist there, and also a bit grey. So at different times there would be waterlogging here when the water infiltrates and then hits a more impervious layer and can't go any further for some time, or moves laterally like this, and this is why we get this coloration here. So you would talk about that, you would talk about how sometimes these colours are inherited from the parent material, and certainly the basaltic material that this is from has lots of iron in it, but also because of this imperviousness, sometimes you have periods where this is waterlogged and has low oxygen, and you get these greeny grey colours, and then when it dries out and the iron is then oxidised, it goes a bit orangey red, like rust. And when you get further to the coast and we have the red ferrosols, there's more of that, and you get those really amazing deep red profiles, and you can show people that. So you can break that open. Sometimes there might be roots in there, and you could possibly see if some of them have been died because of waterlogging. Sometimes it's not that clear, but in some of the root channels you'll see the red from the oxidization. And this is also a good way to check and see if you can see wormholes. So you may not see biology, but you can see evidence of it. So things like wormholes, eggs, that sort of tunneling, burrowing, roots going down old wormholes full with worm castings. And going back to the soil structure, you could choose to look at the structural stability of those. So that's your test with, I advocate the white bowls, which I don't have here, but you can choose to put different PEDs from different levels in the profile and leave them for a bit and see what happens, and explain slaking, and again differentiate it from dispersion. And you would talk about the role of the soil chemistry in that, but also the important role of organic matter in maintaining soil structural stability. So you could do that. And then obviously there's the ones that people are most familiar with, the tests, things like the pH test. Again, I won't do that because I think most of you would be aware of that. You could do that down the profile, and you could choose different increments, particularly if you're in areas where there's issues about the stratification of nutrients and pH. that would be really good to show. So instead of just doing the top 10 centimetres, you might divide the top 10 centimetres up into small increments and show the difference in pH using the kit, and then talk about what that means for management and access to nutrients and things like that for the roots. What else? I haven't set it up, but here's the infiltration ring stuff, which I think I mentioned in the PowerPoint. So these are the ones that are part of the Northern Rivers Soil Health Card, which you can look at online if you haven't already. Now you could set this up on the top, back a bit, and fill it with water, or you could set a larger one up days before, and then you just cut a bit out there and show what's happened with the water. And it might be useful in this kind of soil, given that there's this impediment, to show that if you don't have evidence of that in the profile itself. The other thing that's good to have is keys, and I don't have them on this side of the useful. So I have various pictures of bits of soil biology that you might use, and in the PowerPoint I've also I think put a link in there to the Australian Museum. Has a really good sort of macro soil biology one that is a really good one to have, and you can just download that from the internet if you need to know what to look at. And the other thing, I guess, to discuss while you're in the pit is any other information that you've got around that soil. So if the landholder has some past soil testing or has done some trial work of their own or something like that, then that's a really good thing to include. And it's always good to, as I said, to take a step back from the pit and look at the landscape and where what's happening away from the soil pit face on the soil surface. And you can do things like testing for your ground cover percentage, which is a good sort of indication of some sort of biological activity. You can equate it to some sort of carbon perhaps from their soil test if you have any, and there's you can make a quadrat out of a coat hanger, which is really easy to do like that. So I think that's all that I would cover in a soil pit, but then I would try to get more interaction with the participants, obviously, and get them to do all the tests that I've talked about, and give them handling sheets, and so that they can talk about it. And there's my dogs. So I'll leave it at that, I think.
Oh, thank you for persevering with Okay, this is just again just going over that stuff and some of the aids and things that might help you with doing some of that. So if people are really interested in biology, then you can look at things like hand lens, or you can actually even get little cool little USB microscopes that so obviously that's not so great for in the field, but if you had collected some samples previously, and that means that you can just plug it into a laptop and people can see without having to fiddle around with focus and things like that. So some people find that difficult. And if you're doing that, you might like some ethanol alcohol to collect the bugs in and preserve them in. I mentioned all the other stuff, the yellow book and all that sort of stuff. So I think that I won't labour that slide very much in the interests of time. And again, this just goes over some of the things that, some of the talking points that you might mention with some of those issues. And I guess I mentioned most of them. The main thing I didn't mention was the stuff around structural stability and what a slaking soil may indicate in terms of management and how that soil behaves when it gets wet, and whether it sets hard, what that means for water storage and penetration and root exploration of the soil and seedling emergence and things like that. So you could talk about that, and and just keep relating back what you see in the soil pit to how that soil behaves and how it should perhaps be managed to maintain its health. And then these are some of the resources that I talked about, and I mentioned in the video Ray Wiles' soil pit lab videos, and I think they're a really good way to well, they're really good to watch, and they're really good to see how he presents that information. They're essentially for university students, but just the way he leads you through the soil pit and how he talks about it can be useful. It's good to look at lots of different things like that. I think you can pick up tips and tricks about how to present stuff. I also mentioned the soil landscape maps that New South Wales produces, and they've also got this great online tool called eSpade, which works off Google, which I'm sure Kel's aware of, which is really good to interrogate. If people are interested in that, there's a little, we did a SNOC webinar some time ago with Humphrey, who was one of the people that developed that. So he can lead you through how it works if people would like that assistance. And this is the guide I talked about that's available from the Australian Museum site, which is kind of good. It's just got little sort of line drawings of the different soil macro invertebrates, which can be really helpful if people are really interested in that in terms of identification. I think that's probably all, Felicity. Sorry about the glitch in the middle.
No worries. Thanks, Abby. I'm just putting some links of from eSpade in the chat so people can have a look at that. And I'll find the SNOC, or if you want to find the SNOC.
Oh, yeah, I can do that. I mean, you can also have this as a PDF, and then it'll have all the links in there for everyone.
Great. Yeah, great. Thanks for that. Kel was wondering, is there a soil pit requirements or design for New South Wales? Is there like a soil pit process or handout or guidelines?
You mean like the for the workplace health and safety stuff? Is that what you mean, Kel?
Yeah, what do you mean, Kel?
Yeah, probably both, Abby. The reason I asked is we were planning on having the Soil Knowledge Network guys come up in a couple of weeks and do some soil pits, but that might be cancelled now with the COVID stuff.
Oh, yeah, it's a shame.
Two of the councils are involved, and the first question they asked me was, do you have a design spec for a soil pit so we can double check that that's all right with our guys when we dig them? And I went, that's a really good question. And I searched around and I couldn't even find a basic sort of design that said it's this wide by this deep.
I'll show you one in about 5 minutes.
Yeah,
that would be awesome if you've got one. Yeah.
It's under the excavation in the workplace health and safety stuff. It's under the excavation stuff. I've got something, so yeah.
I searched around for ages and couldn't even find a picture that said design it like this.
I've got a sketch diagram. I'll show you in a couple of minutes that you can. I'll send it to you.
Awesome.
Any other questions for Abby or comments? Richard Hobbs sent me a photo which I'll send out to all of you. It looks like a wet tropics soil pit. Someone standing in a pit with their gumboots on, with it half full of water. No, not quite half full of water, but
probably my counterpart from Ariba on the Wet Tropics tour during the conference. It rained and rained and rained and rained.
Yeah, that's right.
It's not called the Wet Tropics for nothing.
That's it. Yeah, Tim was happy with the walk-in pit, thought that was a good option to consider. Something I've done in the past also is, if this takes a bit of preparation though, so if you have a research site that you've already got identified where you'll be having possibly having a soil pit, I've sown different crop types or pastures or the like in a bit of a row where you're going to have your soil pit, so that when you dig it, you can see the different rooting depths of the different crop types that you might have or pastures. So it's a nice little indication of what might grow and how deep things might grow next to each other. So
yeah, you can do the same thing with if infiltration and water movement is really a thing too. You can do, I don't know if people are familiar with what used to be called the white paint trick. So you mix your 1 part paint and 6 parts water and do that before you cut the soil pit. And then when you cut all, you can see where all the white paint's gone and talk about how that's related to the movement of water into the soil. That's a really nifty thing to do.
yeah, great. Excellent. Thanks, Abby. That was really fantastic. And yeah, just a great overview of what's possible. And yeah, we're not expecting you all to be ped heads, but it just gives you that bit more confidence, and you can rewatch this and yeah, like Abby suggests, just practice to give yourself some confidence if you're talking with a group.
Yeah, yeah. And I think it's all right too to have, you know, if you want that booklet or, you know, the list of things you have to go through in the pit, just have that with you so you feel like you don't forget anything.
Yeah, great. Thanks so much, Abby. And if anyone has any other further questions or comments, please pop them in the chat. So yeah, keep that discussion going. So yeah, now I'd like to introduce Andrew Biggs from Department of Resources in Queensland. And thanks very much, Andrew, for making yourself available. And so yeah, Andrew's going to take us through some Queensland soils info for us. So, and again, yeah, pop some stuff in the chat if you like, or interrupt and ask. So thanks, Andrew.
No worries. I'll start off just with a couple of extra comments about soil pits. And Abby alluded to it at the beginning. One of the most important things about a pit is to understand why you're using the pit. Is the pit the talking point, or is the pit just a tool to facilitate a conversation? We use pits for two different reasons. Sometimes it's a lot of techo talk about exactly what you see in the pit face. And a lot of the times you see Cocky's eyes glaze over and they wander off and look at a piece of machinery or something else. Or the pit is just a pointer in a conversation. And my experience of running dozens and dozens and dozens of soil pits, it's the second one that's the more valuable exercise. Sometimes there will be very specific things in the pit that you do want to draw attention to, but I've watched plenty of people run pits where they've stood there and waxed lyrical about the subangular beds and this and that, and the pits largely are a failure as a communication exercise because everyone gets bored. So be very, very judicious in what it is that you're talking about in a pit, and be very clear in your head what the conversation is you want to have, and don't try and describe everything in the soil pit. And also, Abby mentioned sun angle. That's really important. And if you know you're going to dig your pit well ahead of time, well, then that gives you opportunity to specifically plant a certain crop or other things. Because everything's bigger and better in Queensland, this is what our soil pits look like. We even drove our ute into that one in the bottom right-hand corner. A long time ago, 30 years ago, a colleague wrote a guide to digging soil pits and photographing them. We don't use it anymore because we've learnt that in order to avoid workplace health and safety issues to do with trenches, don't dig a trench, dig a pit. They're two different things. A trench has sides on both sides. It's a linear excavation. A pit is open, and you that way avoid lots of hassles with having to shore up a trench and all that sort of crap. So if you look at the pit on the left-hand side there of the screen, you can see it's a wedge shape. And that's one from the soil judging competition we ran in Cairns recently. That's a bigger version of it. It's actually mechanically more efficient to dig a wedge-shaped pit, and it's much, much easier to get lots of people looking at it, and it's much, much easier to photograph them, and it's much, much easier to deal with variation in sun angle during the day. Over the years, I worked out that this is the optimum design for a pit. It's also a hell of a lot easier for people to get in and out of them, particularly if they're unsteady on their feet or it rains or whatever. So that's my simple diagram about how you dig a pit. I've watched a fella dig a pit like that with a backhoe in 5 minutes. Because if the ground's soft enough, you can actually use the front bucket of the backhoe even and just drive it straight in. If the ground's harder, you dig a trench with your backhoe and then use your front bucket to dig the wedge. And you can always put some little steps on the ramp depending on the material on the ramp. So those are my little thoughts on a pit. And by the way, make sure you have for your pit both a spade and a shovel, because you need a shovel to dig the loose crap out of the bottom of the pit, and you need a spade to cut the pit face back. Spade's flat faced, a shovel isn't. And to get that nice clean face, it's always easier if you've got something very flat faced like a spade. Cracking clay's real bugger, or any sort of clay soil, particularly if it's moist, you often end up smearing as much as picking back. That's when you resort to your gel pick and try and pick it rather than shave it. If it's a sandy soil, anything that's not terribly clay, you actually want to try and shave the face of the pit with a spade. So moving on to getting hold of soils info in Queensland. Well, if you're running a soil pit in Queensland, running a soil pit anywhere really, you want to try and rely on your soil experts around the joint, particularly if you come from more of a generalist background, agronomist, whatever. In Queensland, the experts that you can rely on are listed here on the screen. You'll notice that there's not many people between Mareeba and Bundaberg, and that's about 1,000 kilometre distance. So people are light on the ground. But we are keen to collaborate wherever we can with people, particularly if, for example, we can get double or triple bang for buck out of the exercise. If we use it as part of our project exercises, get decent soil chemistry for the pit and so on and so on. So those people all sit in the agency that Christy and I are in. We call the Department of Resources this week. We'll probably be called something different next week. Our name changes on a regular basis. As far as the information we've got in Queensland, it's a bit different to New South Wales. New South Wales has for a long time relied on the soil landscapes concept. Queensland doesn't use that per se. Depending on where you are, you'll either have very broad scale data, which is land systems mapping, typically 1 to 500,000, 1 to 250,000. In most of the coastal areas, you've got 1 to 50,000 or 1 to 100,000 soils mapping. And in some key spots in cropping areas inland, there is also soils mapping at 1 to 100,000 scale. Even 100,000 scale, your map is not going to tell you exactly what is in the hole in the ground that you've dug at some particular spot. So always be wary of that. All of our information, whether that be the reports, the technical publications, maps themselves, the original printed maps, our site data, that's all digital these days in various web portals, everything from spatial files through to on-screen viewing and downloading PDFs and so forth. We have, as with a lot of other states, in a lot of those reports, there are things like land suitability maps and land suitability frameworks. There's block diagrams or 2D diagrams of how the landscape is put together, how the soils fit in the landscape, things like that. That's roughly the coverage. So as you can see, the land systems cover pretty much all of the inland areas. Soils mapping only really covers the main cropping areas and it skips big chunks of that even. The one in the middle there, land resource areas, that's kind of like land systems. The map units are an amalgam of soil and landscape features, but they're a very specific extension product that was produced from the 1980s into the 1990s. It's targeted very much at landholders, advisors, agronomists, and so forth It's the plain English, if you like, version of the Techo info. It's packaged up in a manner that includes pictures of the soil profiles, general descriptions of the soils, the way they behave, what they can be used for, all presented in colour and a lot easier to read than the Techo bulletins, and very, very much the extension product. So if you're lucky enough, you've got a land management manual in your area, that's the thing really to go to. So that's, examples of what they look like over time. As I said, the land management manual are colour, pictures the soil profiles. Most of the technical bulletins don't have pictures of the soil profiles. So where do you go to get some of this info? The starting point for Queensland, a bit like most of the other states now, is a spatial web portal. Ours is called Queensland Globe. Unfortunately, we're not as lucky as New South Wales, where they were able to build a platform dedicated to their soils info. Ours is lumped up in a whole of government platform. So it has its advantages. In the Queensland Globe, you can turn on everything from electoral boundaries to, gauging stations to anything and everything. Our soils data is hidden in there for reasons that I won't go into. It's lumped under geoscientific information. And in there, you can switch on the point data where we've done site descriptions. You can switch on the different scales of polygonal data, the mapping. And we also have land degradation data in there as well. The Queensland Government Library Catalogue hosts all of our PDF files of reports, maps, all that sort of stuff. You can go to that, search for a publication and find it easy enough, download it. So there, for example, is what you get when you open the Queensland Globe. It's like most web GIS platforms. You go and turn some layers on, you can zoom around, all that sort of stuff. Pardon me, as I said, you can see our stuff is hidden under a layer called geoscientific information. And then we have our soil sites, and then we have a different polygon scale mapping. And here you can see all the soil sites, yellow dots. The polygons are blue. I think they're actually changing colour at the moment. They're going to go to black. Blue's confusing because everyone thinks it's a streamline. You'll notice on the dots that there's a series of letters and a number. All of our site data in Queensland is stored within the National Data Schema Framework, which all pertains to a project code and then the site number. So different projects done for different reasons. So you can see here, for example, there's some P2 reef sites. They're often characterization of research sites. P2 reef is a research program. MISNQ, that's miscellaneous North Queensland sites. They could be done for any particular purpose. ICL in this case was, I think it was Ingham Canelands. It was a soil survey done in that area. So the different letters you'll see mean something. They relate to the project that work was done for. And in the globe, you can click on a site. Up here is a little toolbox thing. You click on it, you can click on the site, and then you can get the plain English description of everything that's there, including laboratory data if it exists. We do have instructions on the web, and Christy can post the URL to those to guide people how to use the Queensland Globe. The library catalogue is easy to get at. Just Google Queensland Environment Library, something along those lines, and you'll find the library catalogue that's shared across multiple agencies. You can get in there and just search it like any other library catalogue. Search for the word soil, search for, Burdekin soils or something like that. You'll find what you're after. Any questions, feel free to email Christy or myself. We also have a generic soils inquiry email address that gets answered by lots of different people. I think Christy will post that in the chat. That's pretty much it. Any questions?
Thanks, Andrew. That was excellent. Yeah. Any questions, anyone? Anything in the chat? Feel free to unmute yourself if you'd like to ask a question. I'll pop it in the chat. I've also popped a link in there to a CSIRO soils. It's called Soils Map, which is an app for iPads. Not sure if anyone has used that or if
Yeah, it's limited in what it can show. One of the problems we have with soils info in general is that it's a bloody dog's breakfast. Every state has done it a slightly different way over the last 60 years. Some states are roughly similar. Some states are quite different from each other in the way that they have mapped what it is that they're mapping in the landscape, how they represent it, how much detail is in it. And then within any given state, depending on where you are, you have all these different types of mapping and scale. So if you're in Western Queensland, for example, you will only have land systems mapping. Land systems mapping is not soils mapping, it is land systems mapping. A land system is a combination of geology, vegetation, geomorphology, and soils. It can guide you to what soils are there, but the only way you actually truly know what soil is there is when you dig a hole in the ground. So that does create lots of challenges for people trying to access soils info. There's only about one place in Queensland that you can go and look at the map and have some reasonable confidence that what you're seeing on the map is what's there on the ground. And that's in the Burdekin, where we have 1 to 25,000 soil surveys. Because to be at the paddock scale or even the farm scale, you have to be at 1 to 25,000 or better. And that scale of mapping is a rarity in Australia, full stop. And there's only one place in Queensland that we have it. So just be cautious that when you're using existing mapping anywhere in Australia, that what you see on the map is not necessarily what is there when you go and dig a pit. For example, in Queensland, we describe up to 4 soil types in a map unit, but obviously we only represent the dominant soil type as the map code. So just because we say that the dominant soil is a Waco, for example, in a polygon, that doesn't mean that that's what's going to be there when you go and dig a hole, because it could be 30% Waco, 30% Norley, 30% Condamine, 10% Bonjean. So you've only got a 30% chance in that instance of actually hitting most of those soils.
I think what Andrew said, I'd second that. That's really important information. And if you're talking to people who, if your farmers or landholders are really interested in looking at maps, just to really impress upon them that. And in New South Wales too, we also have these funny things called acid sulfate soil risk maps. So they're the risk of finding acid sulfate soils there, not necessarily that they will be there or at any depth. And so people often get those really confused. And just to, make that really, make that point really strongly, because I think people get a bit confused about all that.
Yeah, and I mean, I gave the example before of the Burdekin. Even the Burdekin has its issues because the soil surveys were done pre-development. And as part of development, they did an enormous amount of earth moving and land planing. And so there's been serious modification of the soils down to depths as deep as 70 centimetres.
Yeah.
So what was mapped is not necessarily what's there today. But, you never know until you dig a hole, is what it all boils down to. Don't get uptight about the fact that you've dug a hole and it says something different to what the map says, because the map's just a guide to get you to a particular point in space if you're looking for a certain soil type. The map is not necessarily the way that you will choose a site to go and dig a soil pit, because the way that usually occurs, it's the same everywhere in Australia. Friendly cocky, preferably a friendly cocky with his own excavator or backhoe. So it comes back to that question of why am I digging a pit at this point in space? What's the conversation that is going to be had at that pit, and how much does it relate to the pit or features in the profile? How much does it relate to the landscape surrounding it? How much does it relate to the physical properties of that pit face, that soil type, or are you interested in talking about the chemical properties of it, fertility, nutrition, and so on? All of those things are, of course, linked, as Abby, described earlier. You can't stand there and talk about one without talking about all the others, whether it's the biology, the morphology, the colour of the soil, you name it. Colour is where I always start with, because you can tell 90% of the things about a soil profile by its colour.
Yeah.
Yeah.
And it's an easy one for people to relate to.
Yeah, that's right.
Yeah.
Everyone can see colour.
Yeah.
And it's easy for people to remember.
Yeah. Also, I mentioned, I don't know, it used to be the case for eSpade, but if you are into describing lots of pits, they'll often do reciprocal arrangements for you if that's what you really want. So if you give them a couple of profile descriptions, they'll let you access some of the ones that they have that aren't as accessible in terms of information. So just keep that in mind.
Yeah.
Discuss that with Humphrey.
In Queensland, basically, within about 24 hours of us putting our site description in our database, it's visible on the web. Now, one of the things that we run into, I don't know how much you've all run into this, is sensitivity of cockies to do with their data being visible. And for those of you familiar with the National Soil Strategy, one of the pillars of it relates to accessing community data and industry data, landholder data. They're even talking about paying landholders to submit their data. So if you look, for example, in Queensland, you do see quite a lot of our sites are in cropping lands, because that's been a major focus for a lot of our soil survey over the decades. But a lot of those sites were done before the land was cleared and developed for cropping. Or even if they were done in crop soil, we never sample the chemistry in the crop soil. In Queensland, like many states, we have a deliberate bias against sampling for chemistry in cropland, because what we're trying to represent is the natural landscape. But there are a bazillion agronomists out there sampling for fertility and other things in cropping land. We never get that data, and that never goes into our database because we never get it. And so it's not visible through our portals. If you're lucky, you know, in some cropping areas, we do have soil chemistry in the cropped land, but a lot of it could be 20, 30 years old. So something like clay content, well, it's not really going to change. Even CEC is not really going to change much. But if you're looking at other things like phosphorus or nitrogen or carbon, a value from 20 years ago is irrelevant, because that's not what will be in the soil today. So depending on what the topic of conversation is to do with your soil pit, you may be able to perfectly easily use some historical data. You know, you find a dot on the map and you go there to that spot and dig a hole. And if you're really lucky, you find what's in the ground as what was described in the profile description, and you can use the older chemistry. But if you're talking about anything that's a dynamic attribute like pH, organic carbon, nitrogen, phosphorus, so on, you will need to get modern analytical data.
That's also why it's really good to see if you can find a local expert, you know, like you say,
that's right.
the local agronomist or the landholder or whatever.
The other thing to be wary of too, if you are looking at site data, whether it's Queensland, New South Wales, doesn't matter, anywhere around Australia, is that prior to 1990, the way we located our sites was pinprick on an air photo, and then you got your topo map out and a ruler and you measured the coordinates off. So the error in the location of those little yellow dots for anything pre-1990 is 50 to 100 metres. And particularly in Western areas where we only had 1 to 250,000 maps, it's more like 200 to 300 metres error. Anything that's modern, it's been located with a GPS, well, you'll be able to go to that point, knowing that where the point is on the map is pretty darn close to where the real hole was dug.
Yeah, good. That's really good, important information to have and understand the context that we're working in. So excellent. Any other final questions or comments from anyone? Before we wrap up?
I put the links in the chat there, Felicity, for those bits and pieces, Humphrey's
Great.
talk and all that sort of stuff.
Excellent. Thanks so much, Abby. Yep, I've downloaded those, so if people can download them now, that'd be great. Otherwise,
Christy's put in the link to our Queensland Government Soils webpage, which contains, and she's also put in, I think, the email address.
Yeah, she has. So that's great. For you guys to be able to access those. Thank you very much for sharing those, Christy. Appreciate that. Yeah, and a big thanks, Andrew and Abby and Christy, for supporting our group today and for dialing in and sharing your knowledge with us. This is our like I said, our last meeting for this iteration of our phase of capacity building project. So hopefully we'll be able to catch up again soon, but I'll keep you guys posted. In the meantime, I would ask you, and I'll send this in an email as well, but I'll just pop it in the chat while we're here. Like all good projects, we monitor, evaluate and review, and just popped in there a survey for you to be able to participate. So for you guys who have been in the project for the last 18 months or so, we did a survey at the beginning of the project, and now we do one at the end. So it'd be really, well, it's actually a requirement for you guys to complete the survey. So I've just popped it in the chat, but also I'll email a reminder out. But I'll do a report for the end of the project by the end of the month. So thanks again, everybody, for participating